everyone, welcome to our second live stream for Engineering Month. So today we are going to be discussing about computer engineers, and our activity will be related to that as well. So what is a computer engineer? So computer engineers, they fuse electrical engineering and computer sciences together to be able to code machines. So that can be anything from your computer that you're using to your washing machine to your fridge. So any kind of little coding component that had to go into these kind of bigger machines, that was touched by a computer engineer. So today our activity that we're going to be doing together is going to be on Arduinos. So Arduinos are these microcontrollers that allow you to code small little devices such as motors, potentiometers. You can code different sensors like ultrasonic or motion. So you can code a bunch of different little sensors to do different things. So today, our activity is going to be to use a potentiometer to turn a motor. So the website that we're going to be using to do the Arduino today is going to be called Tinkercad. So with Tinkercad, you can do a lot of different things. So maybe you've already used this to do some 3D modeling in the past. Well, you can also use this to design circuits and code those circuits. So all you have to do is to log into your Tinkercad account to get started. So I'm just going to switch screens to get myself logged in. What's really cool about Tinkercad is if you are a teacher, you can actually create a classroom so that you can give your students projects, you can see what they're working on, so it's really fun that way. So once you're logged in, you'll be brought to this home page here, and you'll see I have a bunch of different 3D modeling designs that I've done. I've done a bunch of different circuits as well. But today, that's what we're going to be focusing on, is a new Arduino circuit. So to create a new design, we are going to press on the nice big blue Create button. And we're going to go down to Circuits. So first thing we're going to do is whenever I start a new project, I like to give it a name. So it always generates a random name. So I'm going to call mine Servo. Motor with potentiometer. So that just helps me find my project later if I ever want to go back to it. So I'll explain a little bit what we see on the screen right now. So our screen is kind of divided into two sections, but later we'll make it into 3 different sections. So for now, our 2 sections are our nice middle of our screen, and then our kind of side toolbar over here. So in the middle, this is where we build our circuit. So I'm gonna have to put my Arduino here, I'll have to put my breadboard, my motor, all my stuff that I'm going to be using to build my circuit has to go in this middle component. Where do I get those things from? Well, I get all of my components from the right side of my screen. So right here, already, first thing that I'm looking at is a potentiometer, but I can see my Arduinos here too, and there's a bunch of different sensors and motors that we could code. So our first step is we need to obviously grab an Arduino. So you're going to see right here there's an Arduino Uno R3. So the way that we're going to add this to our kind of sandbox, our building zone, is we're going to click on it and drag it. And once you've done that, it's now at play. So right here I can see that my Arduino is actually divided into 3 different sections. So I have a power section, an analog section, and a digital section. So my power section, that has to do anything with power. So if I want to turn my circuit on, well, I need to be able to give it voltage. So rather I'll give it some 5 volts or some 3.3 volts. Excuse me. And then to ground my circuit, well, it also is going to go into the power section. You'll also see there is a ground on my digital section. So I have 3 different places that I could ground my circuit. So analog and digital, these pins allow me to code different components. So some inputs or outputs, I want them as analog, sometimes I want them as digital. So the way I like to think about analog and digital is I like to use the example of a clock. So an analog clock is kind of, think of, you probably have seen one in your classroom. It's those big round clocks, and they have the numbers like 12, 1, 2, 3, and all going all the way around, and it has the hands. So for example, if I have, it is 1 o'clock, I have my short hand is pointing towards my 1, and then my bigger hand is pointing towards my 12. Let's say it is now 1:30. Well, now my small hand is between my 1 and my 2. And now let's say it's 2 o'clock. Well, now my hand is all the way over on 2. So what this means is an analog pin can allow you to get any number. So it gives you like a concrete number. It can be, it doesn't just have to be 1 or 0. It can be 1, it could be 2, it could be 1.25, it could be 700. It's going to be an actual number. As for our digital pins, well, if we look at our digital clocks, so everyone on your computer, you probably have a little digital clock in the bottom right hand, or on your phone, you probably have a digital clock there as well. If it is 1 o'clock, I see the number 1. If it's 1:30, I still see the number 1. Once it hits 2 o'clock, now that number switches to 2. So the way that the digital pins work is it works in ones and zeros. So rather 0, it's off, 1, it's on. It's one or the other. There's no in between. So the next thing we're going to do is we have to add a breadboard. So that's, again, right on the same line as our Arduino Uno. You'll find a small breadboard. So the breadboards allow us a field to prototype with. So another thing that you call these is a prototyping plate. So it allows you to change your circuit until you get your final result that you're happy with, and then once you have the circuit that you want, you can go and solder it together. So the way the breadboard works is it's separated by 2 sides. So I have my bottom side, and I have a top side as well. They're the exact same thing, they're just mirror images of each other. So at the bottom here, I have a plus row and a minus one. So these ones are all connected. So all these little pluses are connected. So if I plug this into my 5 volts, all of these pins will have access to 5 volts. So that's why when I hover my mouse over one of them, I can see the rest of the line shows up in green. That's to let me know that all of these ones are connected together. And then for my minus, same thing. If I connect this to the ground, then all of these pins are connected to ground. Now, my pins from 1 all the way to 30 that are just above that, these ones are connected vertically instead of horizontally. So I can see anything under 1 is connected together, anything under 13 is connected together. So that's just for us to keep in mind when we go to build our circuit, which we're going to start now. So first thing we're going to do is we're going to go find our potentiometer, which is going to be right here, right under the resistor. And you're going to place it anywhere on your breadboard. One thing that we want to make sure is that each terminal is in a different pin. You kind of have no choice, but let's say you were to rotate it, this button up here rotates it. If I rotate it so that the pins are vertical, they're no longer each in a different section. So we want to make sure that each one is on its own vertical row. Next thing we're going to do is we got to give this thing some power. So we're going to hook up our plus and our minus to our grounds and our power. I like to personally change the color of my wire just to make it a little bit easier to see what's positive, what's negative, what's an output pin. So up here, you can see you can change your wire color. So because I'm going to set up my 5 volts, I'm going to do that in red. So I'm going to go down to my 5. Every time I click with my wire, you'll see it's going to put a bend in it. You don't have to do this. I personally just think it makes it look a little cleaner. So right here, we have connected our 5 volt all the way to our ground, or sorry, our plus. Next thing we're going to do is we're going to do the exact same thing, but we're going to hook up one of these 2 ground pins to our negative. Doesn't matter which ground pin you choose, it's going to do the exact same thing. So I'm going to go back to my wire color. I'm going to change that to black. And I'm going to connect that to my negative terminal. So now all of these ones are going to be connected to my 5 volt. All of these ones are connected to my ground. So now we can connect our potentiometer to our 5 volt and our ground. So terminal 1, which is our first pin, that one is going to be connected to our ground. So you can pick any one of these pins that are not being used. You're going to click on it and just drag it down. And now we're going to do the same thing with our positive, our terminal 2, connect it to our positive. So again, I'll change my wire color. We'll go with red. And I'll just drag that down. So now, my middle pin right here, we are going to connect this one to a analog pin. We're going to connect ours to analog 0. So what a potentiometer does is it changes the amount of resistance that you're giving to any component. So it could be an LED. In our case, it's a motor. So as I'm turning my potentiometer, I'm going to be changing the amount of resistance. And what that's going to do is that is going to change how my motor turns. So because, if you remember what I said about analog is any number, any number. So that's why it has to be connected to an analog pin and not a digital one, because like I said, digital is on or off. And here, I want multiple different values. So I'm just going to change this to, let's go with purple. And again, you'll pick any pin underneath your middle one. And we're going to go and connect this down to our analog 0. And that is all the setup that has to be done for our potentiometer. So next thing we need is a servo motor. So we're going to scroll down. You'll see there's a lot of different kinds of motors, but we want this blue one right here, this micro servo. And again, you're just going to drag that out and you're going to place it anywhere on your screen. Since we're going to connect it to digital pins, I'm going to move mine up. And I'm also going to rotate it just to make it a little bit easier for us to see. So again, we have 3 different terminals for this one. So we have our ground, which is our brown wire, our power, which is our red one, and here we have signal, which is orange. So that's exactly the same thing as our terminal 1, our wiper, and our terminal 2. So we're going to start out by connecting our ground. So we're going to change our wire back to black. And I'm going to connect it to the one up top. But what's wrong with this? I have not given this horizontal row here, I haven't given that any connection. This row doesn't mean anything. So what we're going to do is, instead of re-hooking it back up to our ground and our 5 volt that are down here, I'm just going to connect these 2 segments together. So I'm going to just put one for my negative, and then I'll do the same thing for my positive. And now my ground that I hooked up to my motor is active. So now we can do the same thing with our power, our positive. So we'll come on down. And then the last thing that we have to do is we have to hook it up to a signal. And here's the thing, is you can pretty much choose any pin between 13 and 2. 1 and 0, they kind of work a little bit differently, so I don't recommend choosing them. But if you want to do the exact same thing as me, I'm going to hook mine up to 9. So this is our completed circuit here. Everything is hooked up, everything is ready to go to be coded. So that's my third page that I had talked about earlier, is our coding page. So to activate our coding page, what we are going to do is we're going to go to code in our upper right hand corner. And you'll see you'll start out with some blocks already there, but what we're actually going to do is we are going to code this by typing. We're going to do some text coding. So what we're going to do is you're going to see up here it says blocks. We're going to go down to text. It's going to ask you if you're sure you want to continue. You say yes, because what it's going to do is it's going to erase the blocks that are already there. Let's drag this out. The text is too small for you. You can see there's the A's, the smaller one, and the bigger one. That'll adjust the font size. So I'll make it bigger, easier to see. And Arduinos are fun because they're coded in C++. So that's their coding language. So first thing that we want to do is we want to include a library. So libraries allow us to access different types of components, so code for different components. The way we're going to do that is you'll see there's this little library button up here. And we want to go ahead and find the Servo library. So right here it says servo motors. Let's click on include. And you'll see it's going to add up at the top here. Include servo.h. So that means that we can now use all of the code accessible to us for our servo motor. So next thing we want to do is we want to create some int variables. So int variables are number variables. So the way we're going to do this is these are for our servo as well as our output for our potentiometer. Or sorry, these ones are both for our potentiometer. So we're going to go int, and then you can name your variable whatever you want as long as you remember what you called it and what they do. So you're going to go, so I'm going to call mine sensor value. And then what you're going to do is you're going to make this equal to 0. Make sure every time you finish a line of code, you end that with a semicolon. So our second one is going to be as well an integer value. So we're going to go int, and this one we're going to call it output value. And this one we will also make it equal to 0. And then the last thing we want to do is we want to say that our servo motor is connected to our pin 9. So what we're going to do is we're going to go servo with a capital S. That's very important that you put a capital S here. Space, sensor, or sorry, servo again. Underscore 9. So what this does is it's saying that I have a servo on my pin 9. If you chose a different pin, go ahead and write that number in. So after that, we're going to empty our void setup. So what is our void setup section? Our void setup allows us to set things up. So here we are going to set up that our potentiometer is going to be an input, and we are also going to set set up our servo as well. So what we are going to do is we are going to go pin mode, make sure that the M is a capital, open up a parentheses, and we're going to go A0 because I hooked up my potentiometer to A0. If you hooked yours up to a different one, make sure you write that one down. And then we're going to add a comma, and we are going to set it to an input. So input here has to be written in all caps. And then again, we're finishing it off with a semicolon. So this does exactly what it says it does. It says that my pin 0A, which is my potentiometer, is an input pin. So it's going to give me it's going to give values. So that's the difference between input and output. Output, it gives values out into the world, and input, it receives values. So next thing, again, we're going to set up our servo. So we're going to go servo underscore 9, because I attached mine to pin 9. We're going to go dot attach. And again, we're going to go 9, 500, and then 2,500. These are just parameters for my servo. So that's all you have to do to set up both of my different components. So next thing we want to do is we want to erase everything that is in our void loop. So our void loop is a loop. So pretty much once it reaches the bottom of the code, it starts back. So it allows you, it's kind of like, think of a forever loop. If you've used Scratch before, that's what my void loop does. It'll keep doing the loop until I tell it to end or I stop the code. So what we are going to do is we're going to go sensor value. So if we remember, I had created my variable sensor value. We're going to use that again. But this time, we're not going to make it equal 0. We're going to make it equal to my input that is being given by my servo. So we're going to go sensor value equals analog read, because we are reading the value. And I have to say what pin it's attached to, so we're going to go A0. After that, we have to set our output value, so we're going to go output value is equal to map parentheses sensor value comma 0 comma 1 0 2 3 comma 0 again comma 180. So again, these are my parameters. So this is like my start to finish of my potentiometer. So all my values of my potentiometer, so I have 0 for when it's off. I haven't touched it yet. And then if I go all the way to the other side of it, that is my 1023. And then same thing for my servo. So my servo motor is a 180 motor, so it can only turn 180 degrees. If you had a 360 motor, you could write 360 here. So I have my value 0 all the way to my value 180. After that, we have to tell our motor to turn. So this is all the setup to be able to attach the values of my potentiometer to my values of my servo. So to make the servo turn at my potentiometer, we're going to go servo underscore 9 dot right open up a parentheses, and we're going to put in output value. And then we're just going to finish our code up with a delay. The delay helps improve the simulation. It just makes it a little bit easier for the code to run. Because the code, what it does is it reads each line like simultaneously unless you give it a delay. So here it just gives it a little bit of a break to be able to reset itself. So to activate our delay, we just go delay. And we're just going to set it to 10. We don't need a very long delay. So pretty much the way the delay works is it works in milliseconds. So here it is just 10 milliseconds. And that's it. That's all our code. So to be able to run our code with our Arduino, what we are going to do is we are going to start our simulation. So right here you can see you have a simulation timer. This lets you know how long your simulation has been running. If you're not on very good Wi-Fi, you might see that the seconds are slower than actual seconds. That's okay. It just means that your simulation is just going to run a little bit slower. But now if I click on my potentiometer and I start to turn it, I can see that my motor also turns as well. So I can see, so if I'm at my 0, my potentiometer, if this right here is 0 on my servo motor, if I move it to 90 degrees, I can see my servo motor turn to 90 degrees. And if I turn my potentiometer all the way on, I can see that now my 0 that was over here has made it all the way to 180. So another thing that we could do is we could also have coded this in block form. So if I stop my simulation and I go back to block mode, it's going to erase all of my code, but that's okay. So we are going to get rid of the blocks that are currently there. We're going to go to variable. We'll create some new variables. So this one will be called sensor value. And we are also going to create another variable, and this is going to be our output value. We're going to set our sensor value to an input. So we're going to go read digital pin A0. And then we're going to set our output value. We're going to go to math, scroll down to find the map. So again, we're going to map my sensor value. So we'll go back to variables, grab sensor value. This one might be a little bit tricky. If you don't line up the variable block with the proper circle, it will kick out what you originally had. So just make sure you're lining things up properly. So sensor value, and then we want it to go 0 to 180. And then we're going to go to outputs, and we are going to find rotate servo pin 0 to 0 degrees. Mine is in pin 9, so I'll change that to pin 9. And then I will change the 0 to my output value. So now when I start my simulation, you'll see it does the exact same thing. So that's the end of our activity with you guys today. So I hope you guys enjoyed yourselves and have a great rest of your day.